Mhm. Greetings to the panel members of MIT Vishwakarma University. We are Team Synapse from Vishwakarma University, Pune. Our problem statement ID is 04 and problem statement title is Smart Safety and Assistance System for Sanitation Workers, Solapur Municipal Corporation. Many a times, sanitation workers risk their lives for investigating in risk-prone areas such as gas pipelines or water pipelines. So, we thought an autonomous rover would be a perfect suitable thing to investigate in such areas. So, our proposed solution is an autonomous underground surveillance and navigation rover. It is packed with a 2D LiDAR and a return to home function, which is good for sanitation workers as well as for rover also. We are using dual cameras to see inside the pipelines and map inside the pipeline. First is the thermal imaging, which detects human life and inside smoky or gassy areas where a sanitation worker can't go and it is unsafe for them. And the other we are using is to detect the cracks inside the pipelines using our AI model for normal cameras. And we have multiple gas sensors which can detect the amount of gas inside the pipeline and at what level the gas is spread inside the pipeline. So the sanitation workers don't need to go inside the pipeline and check whether the gas is spread or not, so it is harmful for them also. Then for communication purpose we are using LoRa modules, and some other features of our rover is fog penetrating vision. As we are using thermal imaging, we other features of a rover is fog penetrating vision. As we are using thermal cameras, it can easily penetrate through fog and mark the user or anything which is inside the pipeline. Then for data logging, we are using an SSD. Then it has multiple advanced obstacle avoidance sensor which can avoid the obstacle, and by using return to home function, it can return back to the starting point. Then the technical approach is, as I told, we are using a 2D LiDAR, multiple gas sensors and dual cameras. For this, we are powering with Raspberry and some other microcontrollers, but the main uh, microcontroller is Raspberry, on which we'll be computing our SLAM navigation, which is our return to home function, and our AI model, obviously. Then, for communication purpose of the rover to be fully automatically, we are using LoRa modules, and to storing data, we are using an SSD storage. Then, for feasibility and viability, as SLAM algorithms are proven backly, it is for feasibility and viability, as SLAM algorithms and LoRa modules are proven to be good. It doesn't provide backlash, replaces the expensive crawlers used nowadays, and it eliminates the manual need of sanitation workers to go inside and check every time how much the gas is filled and where the pipeline is leakage is done. So it prevents that, and it prevents major emergency repairs, like if a water pipeline is damaged from one part, the municipal corporation doesn't know where the crack is, so they dig up the whole pipeline. So this big cost can be replaced by using the rover. It goes inside the pipeline and checks where the crack is actually, and it points the data points there, and it can tell where the crack is. So instead of digging up the whole pipeline, they can repair that single point only. Then it is good for business purpose also, as it adapts to oil, gas, and havoc pipes. It is scalable to other pipelines also. It fulfills the regulatory compliances, and municipal corporation can use it as inspection as a service. Then what further risk that we had tackled, that no signal loss. Inside pipelines there is no signal, so we can't control it from outside. Therefore we are using autonomous rover. It has a return to home function. It basically starts from the starting point, and wherever it feels the work is done, it comes back to its starting point only. Then there is a smart voltage monitoring that triggers the battery after a certain point. When the threshold is touched of the battery, then it starts the return to home function and it comes back again home. Then there is no need for manual data storage as it has an SSD storage. And what are the impacts and benefits of this? As it is an autonomous smart rover, it has some smart impacts to the city also, like smart city modernization. It upgrades sanitization with digital mapping and automated infrastructure monitoring. Then it is economically efficient also. Environment protects. It protects environmental by reducing the risk of humans going inside and causing deaths to sanitation workers and fertility prevention. Then what are the benefits of it? It is 100% risk-free inspection. No need of manual interface is required. Fog penetration vision using LiDAR sensors and thermal visions. So, in the areas where there is low vision, which causes problems to sanitization workers, it uh, redu- reduces the cost for that. Then verifiable digital evidence and instant gas abort. Then oh, there are researches also done on these topics earlier. So all the methods are proven and it is not just all hypothetical thoughts. So I hope you like our approach of our rover. So thank you.